Kia ora, welcome to our, I think it's the fourth webinar in our webinar series. We've done Superhome design, windows, ventilation was the last one, and now we're talking about materials. So we're just working through the list of Superhome top 10 principles or top 10 attributes that create a Superhome. And you might be able to just spot that behind me on the Superhome banner there. But future webinars, we're going to be, or probably there's a super systems webinar where we're going to be talking about solar and heating systems and things like that. And then next year, our webinars will be focusing on our design guides and the topics. The people that are contributing to that will be presenting on each of those topics. So just introducing our presenters today. So from BQuest, we've got Owen McLaughlin, and then after that we've got from Character Builders, Guy Gillespie, and then Dan from Dan Saunders Construction. And then if we get time at the end, I'd like to leave time for some questions at the end, and then and a bit of a discussion. So if you've got any questions, just punch those into the chat or the Q&A, and probably the Q&A is better. And then we'll go through those questions. And if we get time, I've got a bit of a case study for our carbon neutral townhouse project that we're working on, the process that we went through to select some of those materials. And then, yeah, it's great that we've got Owen here from BQuest because we're working together on that to calculate the carbon. So I'll just introduce, Superhome Movement. We're a charitable trust, if you haven't heard about the Superhome Movement already, and it's really about raising awareness and open source sharing of ideas to create better, more sustainable homes, and together sharing and doing more and better business for the industry participants. So we've got our participants, and most of those are designers, builders, subbies, suppliers. We've also got a bunch of partners, which you can see on this screen here. And so our main contributors for long-term supporters have been JIB and Brands and Christchurch City Council. But yeah, you can see the rest of them there. And so we've enjoyed partnering with New Zealand Certified Builders. We just did an education day in Auckland yesterday where we talked to hundreds of builders and did 12 classes. It was a bit of a marathon, but I think it's really important that everybody in the industry is aware of super homes and the need for super homes and how to have the right conversations. So that was really good. So the top 10 Superhome principles, which I mentioned, and you can see the materials there: low carbon, responsibly sourced materials. And pretty closely aligned with materials is waste. How do we reduce, reuse, recycle, and how do we manage waste? So, like I mentioned, these are our other webinars that we've done and are coming up. We've had our Superhome tours a couple of weeks ago, so we've now that was great, popular as ever. Hundreds of people visiting a bunch of homes, and then next, we've got our bus tour coming up on the 6th of September, which is a more in-depth and more focused day. The whole day we go around a handful of homes and have lunch, have the obligatory after drinks. It's a very enjoyable day, lots of connections made, lots of learning, and so that's 6th of September. So on the Superhome bus tour, we've got an under construction home, which is great. So you can see the systems and how that's going together. And then we've also got a renovation this year too, which is super. And yeah, I mentioned the design guides. That's our big project, and we're hoping to do a soft launch of this November. And then our webinars next year will be focusing on each of the topics of the design guide, Superhome design guide and Super Reno design guide. Incidentally, if anyone's got any is wanting to be involved in this, just send us an email and we can get you in there. So that's going to be quite it's going to be an online document and a lot of video content. We've started by interviewing the contributors so far, and it'll be a living document, so it'll be updated on a regular basis. So I'll just hand over now to Owen from VQuest.
Thanks, Bob. Cool, I'm in the hot seat. Hello, everyone. So I'm Owen. I'm a co-founder at VQuest. And for my segment today, I'm going to talk about carbon emissions and materials and the landscape associated with that at the moment in New Zealand. It's a big topic, so I'm kind of going to race through all the kind of main key points of that in 10 minutes or so. So my background is a quantity surveyor, so data of materials, cost of materials is something that's always been very important to me. Over the last number of years, I've been involved in quite a few case studies looking at mass timber. So looking at those engineered wood materials and how they perform when they're used in lieu of concrete and steel. So we'd look at those case studies on a building by building, in the building by building context, and see how they perform not only from cost, but also in terms of carbon emissions, so we could tell the whole story. And what we found was, just kind of briefly, I suppose, demonstrate the summary findings from those case studies, was quite often if you use full mass timber throughout the project to maximize sustainability, that would come at a cost premium, but there is a balance of materials where you use the right materials for the right place. What we'd find then is that you could still dramatically increase the amount of sustainable materials in the project at zero cost increase to the budget if you use the right materials in the right place. But often for core structure, we would see results like 20 to 30% reduction in emissions on the core structure, upfront embodied carbon, as well as if you factored in wood storing emissions, so sequestered carbon or biogenic carbon in those materials, that could be up to 70% reduction without increasing the cost. So there's a really important balance between cost and carbon when you're looking at these assessments. So what from leading on from those case studies, we actually got backing from MPI to turn our internal systems that we developed for producing those case studies into a commercial product. So that led us to develop the software that's available on the market in New Zealand today to help with carbon compliance, called VQuest. So VQuest is designed for all those architects, engineers, design build contractors, anybody who is using the likes of Revit, ArchiCAD, and SketchUp. So VQuest is an application or a plugin, whatever you want to call it, that actually integrates into that design software. So as you're working through your design for your building, for your client, VQuest is going to give you, you're going to sync that design into our 3D dashboard, and it's going to give you live feedback on the carbon emissions associated with the materials that you are specifying in your project. So combine not just the emissions, but the cost and even the weight of those materials on top. That now is not just a carbon calculator, but it's a carbon management tool. So it gives you extra granular information on those materials so that you can make decisions on what you're specifying with the intention to either limit the carbon in your building or even potentially reduce the carbon. I mentioned about the case studies, we found low-hanging fruit where it didn't cost anything to increase sustainability, swap out materials, cost negligible, reduce carbon. So VQuest helps you through that process. I guess the final part of that, and here's just an example of that dashboard on screen. So, and then the final part of what VQuest helps with is compliance. So it gets all of the quantities for you designers that are watching in terms of people using Revit and ArchiCAD. It will extract all the material quantities from those 3D CAD models, and it will export them out to the compliance documents does all the translation, the cleaning and the formatting, and it pre-populates those Excel documents. Those Excel documents are brands LCA Quick for full life cycle analysis, full carbon journey of your building over a 50-year period, and the Green Star Embodied Carbon Calculator tool. So on those tools, that kind of brings us to the more serious side of things. So compliance. So when I talk about compliance, what I'm talking about is mandates, mandatory carbon reporting as per legislation passed by the government. What we have here at the moment on screen is the Building for Climate Change work program or roadmap from MB. So there's a caveat on this document in terms of how we're actually going to perform against these deadlines, given we're already in August of 2024, but it's still a live document. It still stands as of today. I'm going to focus on the two columns in the middle. It might be hard to read, but what it says is in 2024, legislation will pass in New Zealand mandating carbon reporting. So from 2025, as part of your consenting process, likely for all residential and commercial new builds, you would need a carbon calculation or a full life cycle analysis done for your project, both operational and embodied carbon. So that's from 2025 on, and then the program brings us right through 2030 and 2050. This document was released a couple of years ago. Given that we're so far in the year since the change of government, there's been a bit of a slowdown on action regarding building for climate change. So look, at this point, undoubtedly, we're probably going to see a bit of a delay in this being rolled out. But we do have international agreements like the Paris Climate Agreement that we signed up to. So it may be delayed, but it will come. And what we're going to find ourselves is in a situation of catch up. So things are going to get pretty fast, pretty quick when it does come around. So I don't want to go on about what is carbon too much, but I do want to hit on what the modules are. So when we talk about carbon and materials, so there's a small box in the bottom there in green, that's your operational energy. So when you're doing a building life cycle analysis, how much carbon is being used or generated when you're using electricity and water and things like that in your building over that 50-year period. Topic of today is on materials, but what I will say is operational energy is actually 50 to 70% of carbon generated from a building. Materials are actually less, they're going to be 30 to 50%. But as we create more energy efficient homes, hopefully continue to insulate homes better in New Zealand, decarbonize our electrical grid, that 70% will begin to drop. So as a percentage, the carbon in our materials of our building actually increases and becomes more of a priority. So we're getting onto that now. So what we have across the top, relevant to just materials, we've got the product stage, A1 to A3. So that is raw materials to leaving the factory or cradle to gate. An interesting kind of point of interest on that, if you were to look at maybe a drywall product or a timber product produced in New Zealand versus the same product manufactured in Australia, you will find that the Australian product often has about 4 times the carbon level. Now, most people would think, yeah, sure it does. We've got to put it on a boat and transport it over. That's where the extra carbon comes from. Not quite the case. It's actually because there's a very high reliance on coal-generated electricity in the grid in Australia, where there's a high level of renewables in New Zealand. So that creates a huge disparity between those materials. So something to keep in mind when it's not just distance from where your materials come from, it's actually the electrical grid that country operates. So that is your kind of material cost, carbon cost, A1 to A3. A4 to A5 is going to be your transport and construction. B, so that is the usage life of carbon from the usage life of that material over the life of the building. How does material still generate carbon when they've been installed? We'll take, for example, carpet. So an example I like to always give is you might have 2 carpet options that you're looking at the start of the project. Carpet option A is lower carbon, but only has a 10-year replacement life. Carpet option B might have a higher carbon, but has a 15-year replacement life. So over the life of the project, over the space of 30 years even, you'll have replaced option B only twice, but the lower one, lower carbon initial carbon, 3 times. So over a life cycle analysis will help you tell which is actually the more optimal choice. In that case, it's probably the latter one. End of life stage and D are also covered in these, but that gets a bit probably more technical than I have time for today. So this slide says the problem. I meant for it to say the process. But there are a few problems in the process. So I'm going to hit on that because really that's the reality of the situation that we're in. So look, ultimately, architects are working with their clients are the specifier of materials, and from a structural aspect, the structural engineers as well. Um, it's a balancing act when specifying materials. There's things to consider. There's the designer's philosophy. There is the homeowner's own preference, what they want to see aesthetically. There's environmental considerations. So if you're in an alpine environment or in there's sea sprays, there's a lot of things to consider. You line all those up. It's a balancing act. It works for everyone. Cool. You've selected your material, but there's more. You got to factor cost. So it's even more complex. There's another layer to the onion. Believe it or not, architects do understand cost, very much so. That's the reason we don't have solid gold bricks for cladding systems. So materials have to be affordable and within the client's budget, especially in residential. You know, architects and clients are making cost-informed decisions every day. And, you know, quantity surveyors often don't come in till later in the project. And in some residential projects, they don't come in at all at any point. So really, architects are helping the client through that budget side of things. And over the years of experience, they've developed a sixth sense for that. They understand what's expensive and what's cheap. You know, you have an understanding of that built up over years. You can make quick, informed decisions. But we're going to add another layer of complexity to that balancing act. Not only does it have to be suitable for the environment, aesthetically pleasing, affordable, but now we're going to introduce we have to look at the emissions of that product. Does it fit within the range that's acceptable? You know, are we building sustainably and in line with what the restrictions are going to be when mandates come and thresholds are introduced in the future? So it's another level of complexity, but we don't have that same sixth sense, that same level of understanding of what's good. We know that wood is good, we know that steel is not so good, and we know that concrete is not so good, but it is getting better in terms of carbon emissions. So but the understanding in depthly for all the products that you're specifying is a bit trickier. If I was to tell you that thermally modified timber had a higher carbon value or emissions value than fiber cement cladding, you know, that would probably be a surprise. And it should be because I just made that up. But ultimately, what I'm trying to demonstrate is you don't have the same sense to call me out on that. We don't have that knowledge base built up. If I was to say aluminium cladding is cheaper than fiber cement, you would know that I'm wrong. So that's just a demonstration. We don't have that built up. So what do we have to do? Well, essentially, we have to look up the carbon value for each of those materials. Where do we get that from? We get that from environmental product declarations. So these are like the carbon nutritional value of a product. They're made by the manufacturers of the product and they're released. They're on PDF documents that are 120 pages long. There's a big table of data on there on one of those pages. You're only after the information in one row, and then you have to get out your calculator and you got to work out an equation. And then you work out the carbon value per kg. And then you have to work out how many kgs of plywood you have. It's a bit of an ordeal. But fortunately, in New Zealand, brands have actually gone through hundreds of those, thousands of those, and brought them all together. So we can easily reference them. Well, not easily, but we can reference them off of CO2 Instruct or a database built into LCA Quick. Same thing, both produced by brands. So that's where they've brought all those EPDs together that we can quickly reference. Sounds easy. It is difficult. Shameless plug for VQuest. This is what we help with. We make it easy to access this information. We make it easy to use inside your design software. Ultimately, when you go to every material you're considering, you want to go and look up the carbon value to check if it's acceptable. This is the extract of the database of the 3,550 materials that are currently available from CO2 Instruct or LCA Quick. When I put them on the page to demonstrate, I thought they looked like skyscrapers. So excuse my doodling where I drew little towers over them. It looks like a small CBD of some description. So that is all the rates. It's very difficult. Even when you think you found the product you need, you'll find that your supplier, the product you're specifying, don't produce an EPD. So you'll go to one that's similar. They don't produce one either. So you'll go to the raw material. Cool. Is my steel coming from Thailand? Is it coming from China? Is it coming from Australia? It's quite a difficult process to even find what you need out of that 3,550 rates. That's one problem. The second problem is kind of counterintuitive to that. This is not nearly enough EPDs. We need 5 times that amount even for a start, because you'll constantly find yourself finding materials that don't have an EPD. So we need the list to be bigger, but then we have the problem of finding materials in that large list also. quite difficult. So look, I'm not going to go on about too many problems and make it too scary. There are solutions out there. There are third-party LCA softwares that help through this process, like VQuest. One thing I'll say though is in New Zealand, in terms of compliance, whether it's an authority or a body, professional body, they do prefer that you use their tools like Brand's LCA Quick or the Green Star Body Carbon Calculator, because consistency is very important to them. They find some of the other tools don't quite always deliver full consistency. So what I would say is, as a final note, is to use this time wisely. There's going to be a delay on when those mandates come in. We have an opportunity here. When it comes around, it's going to be hell for leather. It's going to be go, and we're going to be playing catch up. So use this time wisely. Just get educated. Look at those documents. Look at the brand's documentation. Study the EPDs. Learn more about them, and reach out if you have any questions to me. And I'll leave it there. Thanks.
I'm Guy from Character Builders. So we've made life complicated, haven't we? So I just want to bring us down to earth a little bit in terms of building practice on the ground. So I've been building in Christchurch for 25 years. My company, Character Builders, we build traditional homes, and we specialise in restoration and new builds in an old style. And the big question, I guess, in this day and age is, what is it going to cost me to build my house? And what happens when you have a plan and you have a budget and the two don't really agree? So the stages of building, I mean, you can look at how all the things you have to do to build a house, all the various stages of construction, and you don't need to know that as the end user, but most builders will work through, what's the design, the consenting process. They get through excavation, foundations, the framing, and so on and so forth, and until you get to the end of the job and you're building the decks and the driveway, and everyone's excited, but you ran out of money months ago. And so I want to talk about building on a budget. And what I would say is the first and most important part of this whole process is design. Now, that may seem strange coming from a builder, because usually we builders think that the architects are idiots and they should have done it more practically and all the rest. But actually, we need to stay in our lane and get a good designer, because it's the most important part. And when you get a concept plan that you love and that you've spent time on, or really you do need to spend time on it and think it through and push back with the designer and think about it carefully. And I create a scale model, and that's just fun. The homeowner can build a scale model, as you can see there on the screen. And it helps you to live and breathe the home that you want to build. And don't rush that stage, and gather advice. But what I would say is engage with your builder early, because that's one of the key principles also of budget construction, of finding ways to save on cost. And I want to look at 6 different aspects of savings. So when we built the Hillsborough Superhome, we did it on a shoestring. We had a target. We thought we could build it for $400,000. Well, we were wrong, but we got it close. We were probably shy about 20%, but we kind of got there on a tight budget. And there were 6 things that we did to save. So the first one was, once we'd established the plans and we'd thought it through and we'd pushed back and we felt we got it as small as we could, and everything seemed to be working, we then started sourcing materials. And you don't have to be a builder to do this, but you've got to know what can be sourced at a reasonable cost, because there's no point spending a whole lot of time sourcing nails when you can just buy cheap nails anyway, and the builder will do all of that. You've got to know what that is. So the first thing is, you can buy new alternatives, surplus stock. So we found a steel beam It was slightly larger than the one that was designed, but it was a beam that was a quarter of the price of going to a steel merchant. Rigid air barrier, we found that someone was building a bunch of flats in Spraydon, and they had left over a whole bunch of exterior barrier board. Tapes and wraps, we found again there. We just sourced Facebook Marketplace, and we found time and time again we would find rolls of tape that were $20 instead of $80. Fascia and spouting, which was out at Musgroves, and it was still new. It had the plastic wrap on it, albeit it took us 10 times as long to get the wrap off because it had stuck there after months. Vanity basins, sort of end-of-line surplus, tiles that were both. So there were ways of finding surplus stock that was at a far reduced price. The second thing was material substitution. So the plans called for 21 mil plywood. And when we thought about it, you didn't actually need that because the joist centres accommodated a cheaper 18 mil plywood. And so therefore the plywood was 2/3 the price. Soundproofing layers, instead of putting 2 layers of jib on, we found that you could source 15 mil particle board, packaging materials. And so we were able to substitute that to help with our soundproofing. Cedar cladding, we managed to buy a tree and get it milled and kiln dried, and we ran all our exterior cladding with Japanese cedar from Rangiora. And so the first one is the new alternatives, surplus stock. Second one is material substitutions. The third one is then you go from the new products, you go to some recycled alternatives. Quality secondhand materials. And you're not only getting it cheaper, but I guess it saves it going in a hole and destroying our planet. Colour steel roofing. You can see on the photo, if you look closely, that used to be red roofing. We've spray painted it black. It was 5 years old, been used on a commercial building, so it had very few holes that we had to fill on the ridges. And we were able to source our roofing. Instead of paying $15,000, we paid $1,500 for our roofing. Interior doors, secondhand. We bought them; they were as good as new. Wardrobe sliders, stairs. We didn't do this, but we had in mind to put a new kitchen, secondhand kitchen in. And depending on whether we could afford it at the end, we would have gone secondhand. And that is an option. If you just can't afford it, if the budget just doesn't stack up, then maybe you can make do with a second-hand kitchen for a period of time. So recycled alternatives. So they can be quality second-hand, or they can be upcycled features. There was an old house on the property where we were building in Hillsborough a couple of years ago, and we demolished that and we retrieved the cedar weatherboards from that, put them in storage, and then we made features out of it, like the stair balustrade you can see on the side of the stair there. Lighting pelmets, chandeliers were made from some old church lights from a restoration we did, repurposed them and made a feature of them. Bedside fixtures, all sorts of things that are kind of cool and make a house interesting, but they're from recycled, upcycled features. And then the fifth thing was we used in the process of planning, we sought to reduce our waste, to recycle. So we had bags of waste that were identified that we took to recycle, and we ended up with about a ton of waste instead of 3 full skip loads as you would normally expect on a house build. And as an example of a way of doing it, all the leftover jib board became gypsum soil additive, and you can see it in the picture on the side of the house there, where we basically dug all the leftover jib board back into the garden instead of taking it to a landfill. So waste reduction was one really quite crucial way of saving some dollars at the end. And then the final one is reused or using recycled or reused appliances. In the process of building, we thought about this whole secondhand kitchen idea. So we bought a secondhand kitchen, and with that came a secondhand dishwasher and a secondhand oven, and they were in good condition, and a fridge actually. And so at the end of the day, we decided to keep those three components. We sold off the secondhand kitchen again, put a new kitchen in, but we used the oven and dishwasher and the fridge, and we found heated towel rails, for example, on Facebook Marketplace and bought those secondhand. We put in heat pump for heating and cooling. They were secondhand, and instead of paying $3,000 for a heat pump, you get them for $600. So I guess at the end of the day, what is a super home for you? And whilst we'd all love to have all the very best and go to the nth degree on everything, for most people, we were included, there is a budget and there is a constraint. And so you have to somehow find a way of building your super home and putting into it all the things that are really important to you, and come out having met a budget that you can work with, that you can live with, and have a super home, a healthy and warm home. This time of year, we just love walking into our home. It's beautiful and warm, and it is a comfortable home. We haven't had to spend the earth, and family show up, and balls get kicked around, and the dog scratches the wall, but we love it. It's not perfect, but it's a super home. So thank you, Bob. I'm going to hand this on to Dan.
All right, thanks, Guy, for that. So I'm Dan from Dan Saunders Construction, and we also have the company Eco Panel, where we do prefabricated walls, as you can see there. So what I'm just going to briefly touch on is material selection, similar to Guy, but on a different tangent. What Guy was saying about compromise and upgrading your selected materials and stuff like that is a really good point, because when we talk about new builds, we talk about spending as much money as you can on a thermal envelope, which is the things you can't change, your insulated foundation and high performance walls, windows, and ventilation systems. So having that ability to compromise on those things, and for your vanities and your kitchens and things like that, helps you achieve that end goal, which is good. So as Bob mentioned, we spent the day up in Auckland chatting to builders up there about the holistic approach with what a super home is, from the thermal envelope and things like that. So what I'm going to touch on is using the same sort of think pattern around material selections. So when we talk about material selections in a new home, we've got to think about the overall holistic approach to it. So things like sustainability, end of life. So is it recoverable? Is it recyclable? Or is it reusable? So things like that when you're picking material selections. And again, referring back to Guy with his milling of his redwood tree was great. So things also like toxicity levels, VOCs, ongoing performance, and ongoing maintenance required. So all of those things paint a picture of where your selection process sits. So moving on from that. So the things like toxic materials and things like that, the International Living Future Institute have a red list, and they have a list of building materials that have either ingredients or chemicals in it that potentially can be harmful to living creatures or the environment. So we use that in the back of our mind as to what dictates the materials that we're going to use in these jobs. So things like trading off different products like plywood or any timber that's treated with CCA, which is copper, chrome, arsenic, and swapping that out to things like micronized copper azole, which is good. People use it in playgrounds and in veggie gardens. So whereas where you're putting in things like chromium and arsenic into the soils and things like that is not great. So Also things like plastics, things like in the construction phase, making sure recycling, cleaning, and disposing of these at the end of the job, because we've got to really reduce the use of plastics in construction, because there's a big thing at the moment of where microplastics and how they're breaking down, getting into the soils. They've found it pretty much everywhere, even in areas that humans haven't been before. It's just that, you know, you see with the oceans, they're just covered in plastic. So things like that. Moving on for different things that you can swap out basically in a job. So insulation materials, there's obviously different chemicals that make up the binders and things like that. So having a good look through those options and maybe selecting ones that are using some recycled materials, and you may lose a little bit of performance, but the overall end of use is a lot better. Things like plywood, again, what I say, sacrificing removing the CCA treated plywood and going with something like Saveboard, which is recycled Tetra Pak products, and even OSB products, which have LOSB P sort of solvent based treatments in it. So things like that. We've also got insulation materials. If I go back to here, you know, obviously with insulated foundations, we tend to use polystyrene because it is, or EPS because it is common and it is cheap. But if there was other different products we could substitute in, that would be a great thing. Like for wall claddings, you could go with a cork product. Of course, that's a pricier thing, but that has one of the best R values, and it's a natural product. Things like the cavity battens, you can see there at the service cavity. I don't know if my mouse works here or not, but swapping out treated timber for just untreated timber, Douglas fir, things like that is helpful as well. So overall, basically, it's just having that holistic approach to your mindset around selecting materials and what's going to be good for your health and well-being when you're living in your house. Make sure there's minimal amount of VOCs coming off the products that you're using that are getting into the system. So that's pretty much me for now. So
Thanks, Dan. Yeah, just personally, you know, a couple of things that we've been thinking about is, you know, with our carbon neutral project that we're working on, we went through the process of thinking about a list of what materials, what are the key considerations for materials, and we came up with 10 things. And I've got to admit, aesthetics was top of the list. And you'd expect that with a designer, but yeah, and sort of in no particular order, I just noted down the things when we were looking at cladding choice, and that really helped to guide us. So, you know, starting with aesthetics, you know, the form, the function, the color, how do the details work? Is it going to have an appealing look and finish? That was the first thing. The next thing I thought about was, well, like guys told us, that cost is a big thing, cost effectiveness, value for money, and included in that one is thinking about the longevity. And yeah, so Owen touched on that. You know, if you're going with the cheapest carpet, you know, that lasts for 10 years, it's not going to be as good as one that lasts for 15 years. So the most sustainable material, or the most sustainable building, is a building you don't build, and then the most sustainable material might be the one that lasts the longest, not necessarily the cheapest one. So yeah, and then number 3 on my list was low maintenance, which yeah, it's kind of related to that cost one. But also thinking about exposure to the environment, you know, what's the location, exposure to the sun and the wind, and is it in a coastal location, and all those sort of aspects in terms of maintenance, and how do you actually maintain it? You know, do you need to put scaffolding up if you're going to maintain it? These sort of things. And then sustainability, you know, I mentioned it's not necessarily in any order, my list here, but sustainability, I thought about, well, it's what's thinking about sustainable, but also what's thinking about what's not sustainable. And Dan touched on that with, the International Living Future Institute. That's a bit of a mouthful. They are responsible for Living Building Challenge, which is a very stringent rating, which focuses on materials and beauty and things that other rating systems don't get to. But what is not sustainable? So just the red list that they've created, they have a thing called Declare, which is I think I want to talk about that. So that's like your sort of nutrition label for your materials, but what has the nasty stuff in it that isn't good for our health? What's going to emit gas off and emit harmful, toxic VOCs and other substances into our internal environments that we don't want to have. So that's really important. And then, top of mind, we're up to around eyeballs in this right now, carbon, thinking about the embodied carbon of materials and the whole life cycle, and where do they come from? How are they produced? How are they extracted, transport? And, although energy operational carbon is slightly more, like Owen was mentioning, it's going to become less significant as buildings become better and more energy efficient, and then the embodied carbon is going to take over. And the embodied carbon actually is all expended right at the front end. So that happens at the start, and the operational carbon happens over the life of the building, obviously. So and then other things, just like the buildability and how do you use the materials, and the labour involved and details involved in putting it together, and the design process. What is the dimensionally? How do the materials fit into the build in terms of the sheet sizes and how much waste is going to be and things like that, and having less joints and lower waste. So another thing is compliance and are the materials acceptable to the council. So as we start to use more and more innovative materials, we've got to think about the consenting process, and if it's an imported material, is that going to be accepted by the council and things like that. So those things are improving, but it's still a challenge sometimes. So just finishing off, the other thing is the support that comes with the different products and materials that we select. Is it a good company to deal with? And we've got the benefit of the Superhome movement, where we've got a bunch of really like-minded of industry practitioners and suppliers that understand our values and understand what we're trying to achieve, and are really helping us achieve our goals. And sort of an end-to-end approach where we've got support that we need from our partners with the materials that we're choosing. So probably that just the final thing is what was the final thing? That's probably 10. I guess it is a challenge, and it's I think what we're doing is we're putting in the work at the front end, so that when things like carbon calculation is mandatory, we'll be ahead of the game. We've seen exactly that with the H1 changes. It really didn't affect what we do because we're already doing better than that. I think the other challenge is really understanding some of the claims and avoiding greenwash. So there's so many green labels out there. EPDs are great because that's providing some transparency, but not all green labels are the same. So you need to be aware and really highlighted how to deal with greenwashing, how to identify greenwash, because that's pretty prevalent in the industry. And not all claims are true, so you've really got to dig deeper. Okay, so we've got a few questions coming through now. So, Laura, when using recycled secondhand product like the colour steel roof, is the warranty a consideration?
Yeah, so it is a consideration and an issue. And when you're using anything secondhand, you have to accept the liability of imperfection. And I have a saying that perfection is a myth. And what you're trying to achieve in using secondhand is you're both trying to save cost. You also try to save what so you have to accept that there is a certain liability because there is no warranty necessarily. You actually probably can still lean on the New Zealand Steel warranty for the product, but certainly you're going to have you won't get a warranty from the roofer. So it's not ideal, it's not perfect, but it is a great way of reducing the cost of the building and having a building that is for all intents and purposes functional and durable.
Cool. Yeah, I think that's a great question. You know, it's sort of tied to the longevity too. You know, how long is the warranty of what you're selecting? So next question, do you feel like the government regulation around carbon calculations and requiring these things like EPDs will make innovation, especially smaller businesses, more difficult, especially in the sustainability space?
Yeah, I think there's already movements to try and make it easier. So I think it was not last week or the week before. I kind of described in one of my slides about the difficulty in accessing that EPD values from brands' CO2 instruct. About 2 weeks ago, there was an announcement of a partnership with MasterSpec that's going to make access to that information a lot easier. So it's going to be a web-based solution. I'm sure there's going to be some features and tools around making that simpler. I presume within the next year or two, when we get from where we are today to mandates coming in, that the usability of things like LCA Quick will improve over time as well. So, you know, it was going to be a challenge if we were jumping straight in next year, although it is kind of needed to meet our climate targets. At the same time, I feel like this opportunity and time that we've been given will just keep progressing for our movements. So 2025, we'll see the master spec release of EPD values. Gives us more time to get more EPDs online. I mentioned that was a bit of a problem at the moment. We don't have enough. So we use this time wisely, and people just need to make it known where they see the challenges so that the industry can respond. The industry is already innovating in preparation for that. There's a lot of money being spent by suppliers in big investment to produce those EPDs because they see the market-driven shift. That dynamic change has already occurred. There's a lot of tools and solutions developing. So I think by the time it comes around, it won't be such a challenge as it might be today.
Great. Next question. Hi guys, has anyone heard of the SIPs out there using more natural, sustainable insulation? Yeah, I think there are, but I think it's just not widely known. And I think there's lots of new materials on the horizon, natural materials, and you know, we probably didn't emphasize that enough, but if you can use natural materials, they're usually more recyclable too. So it's a really good thing to think about. So I know there's a company, I can't remember the name, but there's a company down in Otago who are doing straw SIPs panel. They've become quite thick, but and you might not always have the room depending on the size of your site and what your design is, but I think that's the Australian one. And then there's people thinking about and working on hemp as a SIPs panel material. So yeah, I think we're probably going to see in future a lot more options in terms of natural materials and panels made from natural materials. Most of the SIPs to date have been foams, and that obviously uses petrochemicals to create it. Polystyrene and DIR, polyisocyanate. I think even the name sounds scary. But and it's quite expensive too. So yeah, I think we'll just see more and more of those things going forward. I don't think we have any more questions. So what I might do, I was just waiting until the end, see if we've got any time. So this is probably about 10 minutes. Maybe I can just roll into share the presentation again and roll into the case study project that I mentioned I might talk about, which is our townhouse. I've got one more question, Maggie. What about colour? E.g., Guy mentioned painting his roof black, but should the roof be white to reflect light? Good question.
Yes, if you like white, that's a great colour. But
Yeah.
the reality is you have all the options. If it's aesthetics you're looking for, well, the world's your oyster. If it's a reflection of light, well, that's probably a design question. And consulting a designer on what you're trying to achieve by reflecting the light, or you're trying to cast cool. Black was a choice purely aesthetics, and you can. Black is not actually an ideal color for some materials because it absorbs heat, and so for a timber surface, you would certainly be advised to choose your paint wisely in terms of perhaps a cool colors option where it takes the heat out. That's a good question.
Yeah, it is a good question. And maybe a lot of people don't think about that question, but I noticed recently in Australia you have to have a higher, it's regulated that you have to have a higher level of insulation in your roof if it's a black roof or a dark roof. But yeah, like I mentioned, you can get paints from resin, or colours technology where the darker colours reflect the light similar to a lighter colour. So that's a good option too. So you can be fashionable and also sustainable. Yeah. Oh, another really cool product, just because I just randomly arrived on the screen, is wood fibre. So we've used that in a few jobs, and people have imported that, and but it's recently become available through Kingspan Thermocraft locally. Still imported, but what we've found is even with sort of some light products, and we import a lot of windows, we import a lot of products. The transport cost is not actually huge, and the carbon involved is not actually that significant over the whole project too. So contrary to what some people think. So Ngāwhare Parara is the name of this townhouse project, which we're hoping to be carbon negative, or carbon neutral. Yeah. So, and we're sort of on target to do that so far, which is really good. But the overall theme, Ngāwhare Parara, means to bask in the sun or to warm oneself. So we're starting with the idea that we wanted to separate out these 4 dwellings and have good quality of natural light into all of them, and as much sun as possible, because human beings just like sunshine. And here's the plan of the 4 townhouses. So they all have gaps between them where we've got courtyard spaces and some landscaping. So we're thinking about livability, not just sort of maximizing people before profit. And yeah, and exactly the health and the livability. And then some of these renders, early renders, it's sort of evolved a little bit since here. This is just in for consent at the moment, but some of these early renders show how the sun's really penetrating into the living spaces, which is what we're trying to achieve. But also thinking about not overheating. So we've talked about declare and red list. Another thing we did with this project is the tenants just moved out of this villa yesterday. So we're getting this ready to be put on a truck and taken out to North Canterbury, where it will be finished. We started renovating this. We put in UPVC windows, NK windows, and it made a huge difference. So this photograph here is actually before we did that. So we did a bunch of things, and then we thought it's really great if we can save this house and not have it trashed and smashed and go to landfill. So that's cool. So before we even start on site, we're thinking about sustainability. Yeah, so I think I'll just switch back, stop sharing the screen now. So my list of 10 attributes or 10 considerations for materials, just off the top of my head earlier, that really came about through thinking about the cladding. So, I mean, obviously there'll be slightly different list of things to think about with different products, but we sort of landed on this material here, which is WeatherTex. And you can either have a natural finish with sort of a wood grain effect, or you can have a pre-primed smooth finish. So we're actually using both. And so this is a great product in that it's made from wood fibre from Australian hardwood. There's no harmful chemicals or anything. And in fact, you can take the offcuts from this and you can chip it up and put it on your garden. And so that's super cool. I like the idea of that. And it also comes in quite a large number of sheet sizes. So there'll be less waste because you've got more choices about the design, and the sheet sizes help with reducing the amount of waste. Another thing we're using in this project is Akoya, and this is Akoya Grey. So it's basically, well, it is New Zealand pine, and we call it pickled pine. It's basically marinated in a vinegar solution, and it's got great longevity if you use this one. You can get a natural one which you can stain. There's different finishes. This one is a grey, which the colour is impregnated right throughout the material, which is going to be great because it's going to need less maintenance. You can also char it. So there's some yakisugi. Yakisugi is originated from Japan. They've been doing it for 400 years. This is actually a Japanese piece of cedar here, and well, some people call it shosugi ban, I think, but yakisugi is what I call it, and what they call it in Japan. But basically means barbecued cedar. Sounds delicious, barbecued cedar. But yeah, so there's a lot of options when it comes to sustainable materials, and safe board. I think Dan mentioned safe board, but using that as a RAB, or you can use it as a rigid air barrier. So, and that provides you structural bracing. I think it's a pretty similar price to plywood too. You can use it as a interior lining. We're going to use it in the garages and some of the service spaces, and it looks quite cool. I think it's made from recycled Tetra Paks and soft plastics. So that's it. That's just touching on some of the materials that we're using. One of the homes, we're sort of experimenting with different structural systems too, and probably the main one is the floor. So we're using piles and suspended timber floor instead of concrete. And yeah, so that has a big impact. So I think we're at time now. So I've rabbited on about that for enough. So thank you very much for joining us today. Just keep an eye on the website for the future webinars and events and what's coming up. and enjoy the rest of your day.